My job is as a weather presenter, journalist, meteorologist at the BBC. Obviously, my job is to present weather forecasts on all of the main BBC programmes across TV, radio, increasingly online, social media now. And then whenever anything significant happens in the world, be it a hurricane, a typhoon, the 40-degree heat wave we had in the UK this summer, another part of my job is to appear on news programs as a sort of expert voice. So really, when you boil it down, my job is all about communicating science and data, which I guess is exactly what we're all here to do today. So yeah, maybe I can give you some tips. And if not for today, maybe some things for you to take away for when you do things like this in the future. As Tom said, I was a journalist before I was a meteorologist, so communication has always been what I do. My first job was at a very small local radio station in Bristol. There were only 3 of us on the news team. We covered 3 different radio stations all day long. And after just a few months in the job, I found myself as the main presenter of a half-hour lunchtime news program. And that is a lot of airtime to fill, when a lot of the time I was producing this program single-handedly because the other people were out on late shifts or were reporting on things. So I would be producing the program all on my own, writing the scripts, doing the interviews. And the thing that you realize is that when you stand in front of a microphone on your own in a radio studio, you've got 30 minutes of airtime to fill, and your scripts are only half written and only half the program is there. That teaches you a lot about communication and dealing with pressure and dealing with adrenaline pumping. So I did that job for a while, but I then moved on, as Tom said, to present the weather on Midlands Today for the BBC in Birmingham. They taught me about TV, a lot of training, a lot of screen testing, and also quite an embarrassing trip to the makeup counter in Selfridges. But that's probably a story for another time. Talking about the weather on TV all the time just made me want to learn more about it. I'd always been fascinated in weather since I was a child. I thought I had quite a good grasp of meteorology, but I decided it was time to go and do some proper training. So I joined the Met Office, trained as a meteorologist. I thought I knew about the weather before, but it turns out I didn't know very much. That was such a learning experience. And I guess the main thing I would take away from it, I used to see the weather as a kind of 2D thing, 2-dimensional, just things moving across the ground. And what that course taught me, if I could boil it down to a nutshell, is that actually it's what goes on up there, high up in the atmosphere, that is far more important and far more powerful, and vertical motions that really drive things. I just got such a deeper understanding of how the atmosphere works. And I then went to work at RAF Northolt. So that's an RAF base in northwest London. And my job was to provide forecasts for the airport. So if you've ever been on a plane coming into your destination and you hear the captain say the weather at Magaluf is 28 degrees and there's a few clouds and a light wind from the west, well, I was providing those sorts of observations. That's where that information comes from. Forecasts to keep the airfield safe. And also briefings for our flight crews. So before flight crews went out on missions, which could be in the UK, or it could be to the Middle East, or it could be across Europe, they would come into the office and I would talk through with them what the weather was looking like along their routes. So things like turbulence, ice on the aircraft wings, would they even be able to land when they got there? Where might they have to divert to? Maybe you should delay or cancel the trip altogether, although they were never very keen on the cancellation option. But the thing that this really taught me about communication is that every air crew and every job they were doing was different. So it might have been just a training exercise that could be delayed, or they might have been flying the Prime Minister somewhere, which obviously couldn't be delayed, and so was much higher stakes. And the thing I learned is that it is incredibly valuable to find out as much as you can about who you are communicating to when you are giving that information. So I was able to build up a close relationship with all these flight crews, find out exactly what they wanted. They even took me flying to see for myself the impact of the decisions that we were helping to make, the information we were giving them. And so that knowledge of who you're talking to is so key when you are thinking about communicating data and science in whatever context that might be. So all of that led me to the BBC, and I will share my screen now, and let's see if this works. Maybe not. Just a second, sorry guys. Where's it gone? Sorry guys, it's not crucial if I can't anyway. Right, okay, let's just try and do this. Okay, you probably see my calendar now. Let's just see if I can show you my slides. There we are. Okay, can you see all my Zoom gubbins in the way as well? Okay, well, let's carry on and hope for the best. So hopefully you can see some pictures of me at the moment. But yes, I now work at the BBC, and I communicate weather information, not to individual flight crews, but to viewers, listeners, social media users, right across all of our platforms, from the 6 and the 10 o'clock news to BBC Breakfast, Radio 4, Newsbeat on Radio 1, World Service, our Twitter accounts. The list is endless. So how do we create a weather forecast? Well, it is all about data. And I'm sure a lot of you guys know about this already, but a huge amount of what we do in weather forecasting these days relies on supercomputers, on computer models. So the computer model at the Met Office, for example, the supercomputer takes in weather observations from satellites, from the ground, from radar, from aircraft, all sorts of other sources, gets fed into that supercomputer. It doesn't look very sexy, as you can see from the photo there. But this one takes in 215 billion weather observations, apparently, and does what I'm reliably told is 14,000 trillion calculations every second. And I don't know a lot about computers, but that is a lot. And that computer then produces what we call model output. So this is just a forecast model chart. And you can see that's the weather that one of the European computer weather model forecast for 12 o'clock tomorrow. And the model runs several times a day. There are models from the Met Office, from the European Centre for Medium Range Weather Forecasting. There's the American GFS model. And what our forecasters at the BBC do is they kind of take all of that information in. So we have a company called DTN who provide our weather data. They take all of those model outputs, they have a look at them, kind of critically assess them, and have a think about which computer weather model is doing the best job to tell the story that we want to tell. So I then get, when I arrive at work, a briefing from our forecaster, and maybe I'll ask questions, maybe I'll question some of the things in the briefing, because as a meteorologist, I often have my own view on things. But ultimately, what we have to come up with from all that data is a consistent story, and that's really important. We have to know what it is we want to say, what our story is, and what the key points of the story are. So today, for example, there's a band of heavy rain moving eastwards, could be enough rain to give some flooding, squally gusty winds with that as well. And so those are the kind of key aspects that are going to affect people's lives, and those are the key aspects we need to reflect in our forecast. So what I then have to do is create all my broadcasts. On a shift, I would typically have 15 to 20 different broadcasts to do on TV, radio, online, from 30 seconds on Radio 5 Live to 3.5 minutes on Countryfile on a Sunday night. So a whole different range of different outputs to service, if you like, different channels to provide weather from. And for the TV bulletins, I build, and I'm sorry, this is a photo taken from a TV screen, so it looks a bit weird and funky, but what we basically use to create our TV bulletins is a glorified, powerful PowerPoint system, essentially. So I tell the computer what I want it to show through the timeline. So do I want it to show a photo, satellite picture, some text, weather data, pressure charts, all those things? How long do I want those things on screen for to tell the story that I want to tell? That is always the key. What is it I'm trying to say? How can I use these graphics to help me? And then when I get into the studio, I load it up and it pulls in all of the latest real-time data. So you've always got the latest and most up-to-date forecast. Now, most of our broadcasts come from a green screen studio. It looks very small because it is very small. People often expect a studio with a big crew and loads of camera people and sound people, and we don't have that. It's just all self-operated. The camera goes up and down to match the presenter's heights. It's all operated by a touch screen. And as you can see there, we've got a green screen in the background. And as you may well know, what the green screen does is whenever the camera sees green, the computer replaces the green with the graphics. So what you end up with is a mix of presenter in front, graphics behind, and you've got something to interact with and hopefully tell that story in a dynamic way. And on that, this is what I see. There is no script and there's no auto cue. So all I have in front of me in the camera lens, which you can see just in the center there, is me with the graphics. You probably can't quite make it out because it is quite small. It's too small to really read when you're presenting, you know, what is on the screen. You have to sort of vaguely remember what you were planning to say. And there certainly isn't a script or an auto cue. And that is partly to allow us to have flexibility. So sometimes our timings will get cut or changed or even extended at very late notice. You'll hear in your earpiece that they want you to talk for an extra 30 seconds or cut by an extra 30 seconds. And if you had a script, it would be really hard to edit in your head. Whereas this way, we can just edit as we go in the presentation. Also, it allows us to just be more dynamic because what we're always trying to achieve is a bit of context. So we're trying to tell people a little bit about why the weather is doing what it's doing. Are the temperatures higher or lower than we'd normally expect? How is the jet stream spinning up an individual weather system? I mean, you can see that I'm moving my arms around all the time. It's kind of a reflex reaction, but presenting without auto cue gives us a lot more freedom to be more dynamic and expressive and hopefully be kind of engaging, but also memorable, because that's the key thing. We've got 2.5 minutes to tell you about the weather. We hope that you'll remember some of it. Now, one of the key challenges in communication of weather is uncertainty, because the weather is by its nature uncertain and changeable. And I'll show you these two different weather models. So we talked about computer models before. On the left, you've got the European weather model, and on the right, you've got the American GFS model. And they are both giving you forecast weather data for the same time on Sunday afternoon at 3 o'clock this Sunday. So it's a real example. And as you can see, the model on the right has loads of rain across the southeast. The model on the left has no rain across the southeast because it's all gone over the near continent. The showers in the west look all right. So we can kind of say, okay, we're quite certain that there'll be showers in the west of the UK. But that rain in the southeast, if we're trying to tell a weather story for Sunday, that's really not very helpful. So what we have to do is kind of look at all the information we have, decide which is most likely, but then probably express some uncertainty. So I might say, well, the rain will clear from the southeast, but there's uncertainty about just how long that will take and how quickly it will happen. So that's one thing. But one of the problems that we have these days is that if you're under the age of 40, which many people here will be, you may well not have seen me on the TV. You probably don't watch the TV very often. You'll probably be more reliant on your weather app. And you don't have a presenter to tell you, oh, well, this might happen, but it looks unlikely. All you've got is a weather symbol. These are 3 different weather apps. Took these just before the call, before I came on this. And you can see they will come up with 3 different forecasts anyway. BBC on the left, Met Office in the middle, the iPhone weather app on the right. And you get the infuriating sunshine and showers symbol, which you can see a few times on the BBC forecast on the left. Now, what does that even mean? Sometimes it might mean there's a small chance of a shower, but it'll probably be dry. But if it turns up, the shower will be heavy. Other times it means you'll definitely see a shower, but it won't be raining all the time. And there's so much nuance in that the apps just cannot get across. One way we try to get around that is through probability. What is the chance of rain? You can see the percentages, certainly on the BBC app and the Met Office app at the bottom there. But even those cause problems because people we talk to don't even understand what they mean. So some people will see that 53% at 4 o'clock and a 53% chance of rain, and they'll say, oh, well, that means it'll rain for 53% of the time, or it'll rain across 53% of an area. And it doesn't mean either of those things. It just means in 100 of the same circumstances, it would rain 53 times in one spot. But trying to explain that to people is very, very tricky. And if anyone has an answer to that, I know we would be really, really pleased to hear it. So there are real challenges in communicating. The further away the audience get from the communicator, and almost these apps are putting a bit of a barrier. They're so easy to use, but they put a bit of a barrier between the communicator and the audience who needs that information. So I've talked for quite a long time. I'm going to shut up in a moment, but I just wanted to try and sum up some of what maybe you can take away from what I've said. Firstly, know your subject and be credible. That is so important. I know that this is a little bit troublesome on social media these days about how experts are seen, but I do firmly believe that the more you know about your subject, the better researched you are, the more credible you are, the more likely people are to listen to what you say and to take you seriously. What is your headline? In journalism, we have a thing called a top line. So what is the main point of this story? And whether you are talking to an individual or a room of people, or doing a tweet, or sending a press release to a journalist, making it clear what your key point is will mean your listener doesn't waste time working out for themselves, first of all, but it also helps to prevent miscommunication in that situation where someone might, you might write a piece, an article or a paper, and then you tell some newspaper about it, and then the headline, and it's not the headline you wanted. It's not the message you were trying to give. So at least if you know what your key message is, you've got a fighting chance of getting it through. What's the medium? What do I mean by that? I mean, is it for TV? Are you doing an interview for TV or radio? Are you writing an article? Is it a tweet? What works for TV, for example, in our world, doesn't necessarily work for radio, because TV is visual, radio is just words. So that's really important too. And as I said, around my sort of forecasting for RAF pilots, who are you talking to and what do they need from you? So knowing that will give you a fighting chance of being effective in your communication. It would allow you to tailor what you're saying to the audience that you're talking to and hopefully get your message across better. And the reason why all of this matters, I suppose it's obvious, really. For me, there's no point in my colleagues or I coming up with the most accurate weather forecast in the world if I can't tell anyone about it to make use of it. And it's the same in all aspects of science and data. You can have the biggest scientific breakthrough, the best data in the world, but if you can't communicate it to the people who need to hear it, then what even is the point? I hope that's a little bit helpful. I definitely went past my deadline. So if there are any questions or anything else, feel free to shout across.